So, hi all. So, my name is Marc Bailly. I'm working in Orange on OpenStack cloud solution design and deployment, and mainly for NFV use cases. And I'm here with Bertrand and Juan, and I will let them introduce themselves.
Okay. Hi, everybody. I'm Ryan He. I come from Tencent. I work especially in several projects in OpenStack, including OSLO, Keystone, and also I worked for the OpenNFV Moon project. The goal is just try to have a federated cloud to support the telco infrastructure.
And I am Bertrand Roux. I work at Red Hat. In this role, I collaborate with a key telco partner, Orange being one, on identifying gaps that we may have in OpenStack and bring those gaps into visibility for the community and eventually see those implemented upstream.
Okay, so today we'll address the question about identity and access management, so in this telco private cloud context. So agenda for today is that we will share some of the use cases that we have in our deployments and how we can fulfill them with OpenStack at that time. And then we will move to another approach, which is to centralize the identity and access management. And based on this, on the concept to have an external policy decision point. And Juan will detail what has been done in this OpenNFV Moon project. So a little bit of context. So when we speak here about telco private cloud, actually it's multiple data centers, and these data centers are geographically distributed, and each of them is a complete OpenStack deployment instance. So which means that they are all independent and autonomous. They all have their own Keystone database, and at that time, so we do not rely on Keystone federation, so to keep them fully independent. And so which means that all instances have their own, so they are independent user authorization lifecycle. And to complete the picture, at least in Orange, we are relying on an external SDN controller. And so it's also the case of some other telcos. So when we move to the question about identity and access management in that context, with standard deployments, so we are not able to centralize the authorizations. So typically, in our case, so we are deploying these several data centers, and we deploy VNF on top of them. But and we have a common team that is operating these different data centers. But one of our pain points is how do we handle the question about granting the permission to that common operation team or to the people that are operating the VNF in a consistent fashion across these different data centers. And so typically this means how can we grant consistently privilege and roles to given users across these deployments? How do we ensure that the roles that we are defining are the same across these OpenStack instances? And how do we ensure that the associated policies can be handled in a consistent manner? And in addition to that, how do we handle the point about handling role-based access control in a common manner between OpenStack and SDN Controller? So that's why we have identified quite high-level requirement here is that we would like to centralize the authentication, centralize the question about role assignment to users, centralize the policy management, so the permissions that are attached to each role, and how do we handle to get a mechanism to have a consistent authorization between OpenStack and external SDN controller. So for each of these requirements, we will try to explain how we are handling them today. So for the question about centralization of authentication, it's quite easy. It's well supported in OpenStack. So we can rely typically on a centralized LDAP with a cluster-based mechanism. And so this is typically what we are using at that time. Or we could have also used Keystone to Keystone Federation, but this was not our choice. Then when we move to the question about role assignment, so as I was mentioning, so we would like to get the operation team, either for the cloud itself or for the VNF, to get a same role on the different OpenStack projects that are used to deploy a VNF. But at that time, it's not easier to handle that in OpenStack today, because each keystone has its own local database to store the roles that are assigned to users. And so the way we handle it today is that we need to deploy another external system, so that we call here the assignment system. And this component is responsible for granting and synchronizing all this role affectation to users. So which means that each time there is an update on one data center, we need to replicate it on the other time to synchronize this. Then the next point is, Bertrand will detail it.
So basically, one of the requirements that is around like a centralization of a policy assignment, right? Today, if we look at what is being done, we have for each independent OpenStack service and for each OpenStack instance that is being deployed and for each data center, we have this endorsed through the OSLO Policy Engine, right? So like I said, for each service, for each OpenStack, for each data center, right? And also this policy assignment enforcement is based on rules that are defined in policy files. And we have one policy file per service. So if you see the picture, this could get fairly complicated when you need to handle all those files in a consistent manner. And I'll show you some example of policy files so you get a feel for it and the challenge it can present. Another thing that is important is the notion of role, right? If we look at OpenStack today, basically there is a very minimum set of roles that come out of the box, let it be admin or member. And we know that in the case of a telco to be compliant with a security agency like ANSI in France, we need a finer control, finer granularity on those roles, right? We tend to give assigned role to user, and we know that those users have way too much power. So we need to be able to kind of scope it way much better. Just to give you an idea of on the policy file, so it's basically two parts. We have a set of definition and a set of rules. The rule is where we have like a target, meaning like an action that the user is trying to perform. And the second part is the rule, where this is a set of checks to see if this operation is going to be granted to the user. Just to give you an example, we have like a policy.json for Nova. This is just a subset. Again, you see the two parts where you have the definition and the rule below, right? As you can see, this is just a subset. Depending on the service, you may have like a more definition, more rule. But it's just to tell you that, I mean, you could go from 100 to 1,000 of lines. So that's become complex fairly quickly and not necessarily easy to manage. Just, again, focusing on the policy itself, just to give you an example of what it would look like to define a rule to, let's say, allow a user to list instances. So you will see that there is a lot of effort upstream to define a read-only role. So that's the reason why I'm picking up on that example of read-only or auditor or reader role. So here, what we can see that we have the definition that I mentioned, the read-only, and also the second line being the actual rule itself, right? So what does it mean? In the definition, we check that the project ID of the user that has been authenticated is actually compared with the project ID of the resource we're trying to access. And also we check that user has a read-only role. I mean, the read-only role being the one defining keystone. And then eventually the rule checks that if you have a admin, if it checks the rule admin or the rule member, or know that new rule read-only, then you can perform the operation. So the motivation to show you this example is it can get very complex quickly if you try to have a special scenario, or you may have also dependencies between services. So long story short, managing and defining those rules is a daunting task. Like I said, some of the services have a fairly large policy.json file. I mean, It's not always easy to understand. The flexibility may not always be there. And in the case of having multiple OpenStack instances running in many data centers, trying to keep those in sync is really a challenge, right? We could be in a situation where some of the policies have been updated on one data center and not replicated properly on the other data center. So we could be in security violation because we're not consistent across all the data center.
Yeah, and then to complete the picture, when we add the SDN controller, as I was mentioning, that we are using in our deployments, we extend the problem also to the role-based access control for SDN controller. So which means that at this stage, so these two systems have two independent ways to handle that. And when you need to grant roles to users on OpenStack, on SDN controllers, it extends the role of this assignment system, so in blue here, that it needs to address the exact same consideration for the SDN controller. So which role do I grant to the user? What are the policies? What are the permissions that we grant to a specific role? And for this, we need to deploy that kind of tools that is granting this role and that is synchronizing any updates that we need to do across the different data centers. And then, based on this, so it's not that easy to handle, it's not that easy to keep that kind of synchronization, especially when the number of data center scales. So if you're one or two, it's not the problem, but when you get a higher number of data center, it's become a pain point for us. And this is in that context that we have been looking at an alternative approach that Juan will detail.
Okay. Firstly, I just try to give you a brief summary about the difference. So first, we talk a lot about OpenStack, Keystone, its approach. The problem that we discussed with the community to present the telco requirement about the IAM. So from Keystone side, we think that we need only one module, the centralized Keystone, to control all the OpenStack. In OpenStack, when we talk about multi-cloud, means that we have one Keystone which will pilot several OpenStack together. This is the approach from OpenStack. However, from the telco side, we don't believe it. For which reason? All the requirements we presented previously. And then what we need here is really a distributed OpenStack in the sense that we have each OpenStack stack for one data center, or we call it NGPoP, or we call data center, telco data centers. And then we try to have a solution to federate all this together. So another requirement very important. So OpenStack, we talk about cloud computing. However, in telco side, we have another very important modules that we should handle is the SDN controller, OpenDelight, or also other SDN controllers. So the IAM module should also manage the SDN controller together with OpenStack, multiple OpenStack instances. How to do that? For these reasons, we try to use an approach in order to separate, we call it the data plane and the control plane. Means that each OpenStack or SDN controllers are considered just as a data plane instance. And then we add another layers for the IAM control. The layer we call the control plane, the Moon project, just to implement the control plane. Just to give you a very simple example, means that imagine in the case we have several OpenStack. So in the OpenStack, we can create several, we call it IAM manager or security manager or tenant managers to control each OpenStack, to control each tenant in the OpenStack. And in the case if we like to have the OpenDelight as the controller, we add another module just to control another manager just to control the OpenDelight. So another very important difference is that in the OpenStack side, when we talk about the policy is global for all the projects or tenant inside OpenStack. However, from the telco side, what we need is for each tenant, we need a dedicated or customized policy for this tenant. So what we do also is that in the control plane, for each tenant in OpenStack, we create a dedicated manager which includes a policy to do that. So Bertrand just present you the format of the policy.json file. So we use another approach. we don't use this policy.json file because this is a global one for all the tenants in one OpenStack. So what we need is one policy for each tenant. To do it, since all the tenants are created dynamically on demand, so what we do here is all the policies, or the policy manager, or here we call it tenant manager, are created dynamically based on the creation or the removal of the tenant. So now, this is just a data model that we describe the policy. Very important thing here, how we can support these kinds of customized on-demand policy. I create a new tenant, how can I create a policy to describe the requirement, security requirement of this tenant? It's not easy work. So what we defined here, we defined we call it a data model. Through this data model, we can customize policies for each tenant. So previously in this week, I attended another presentation by Red Hat, Adam Young. He presented just the approach of RBAC, role-based access control policy. So RBAC is a very good policy model. However, it's not the unique policy model. So why I say that? Because in the telco side, we don't really use RBAC. RBAC means that, okay, role-based access controls. For the users, we create a roles, and we attach permissions for each roles. But problem that from telco side, we talk more about the information flow. So all the traffics are considered as the information flow. So we use normally MLS, multi-level security model instead of RBAC. So we need a data model which can support at the same time RBAC and the role-based access control and multi-level security. And for this reason, so we have these data models which is proved to be a generic data model can support different policies. Okay. So how it works, another important thing is different aspect. When we work on the policy, different people, so different actors can work on the same policy. For example, as the infra admin, I work on the policy, try to define some basic guidelines. And then as a tenant admin, I try to work on the policy for some privileges. And at the end, as the standard users, I try to fetch some roles, and I also need to work on the policy. So one policy should be treated by several people. This becomes a very different issue, very difficult issue, sorry. How to do that? For this reason, in the Moon project, we proposed a solution, we call it policy chaining. So one policy to resolve all these problems is impossible. So how to do that? We create several policies, and each policy treats only one aspect. And behind these policies, we defined a training mechanism in order to train or to route all these policies together. And since each policy treats just one aspect, and if we route all these together, we combine all these policies together, we can treat multi-aspects. Technically speaking, so what's Moon? Firstly, the Moon is an implementation of this approach. We call it software-undefined access control. Means using the dynamic approach, using the dynamic data models to create dynamically the policies for different tenants. And it's based on the microservice architecture. When I talk about a microservice architecture, this means that, okay, or if I go back to this slide, all these modules in the control plane are containers, are Dockers that can be created dynamically. At the beginning, we defined a Docker image, which implemented the data model. And when we launch these Dockers, and we can specify the data model or the policy we used for this tenant, these managers. Once we defined it, when the Docker is launched, it replaces the role as a tenant managers with the dedicated policy. First, it's based on the microservice architecture with tenant to represent each manager. Secondly, we use the master-slave architecture. For telco reason, we need a very, very high availability. Since that we have several data centers which are dramatically distributed around the world, and maybe the connection between different data centers can be interrupted temporarily. how to handle this, we use an approach called master and slave architecture. So all the information will be firstly stored in a centralized data center or centralized IAM module called master. And then for each local data centers, the telco NGPoP data centers, we have a cache, a local cache about the useful information for local usage. If the connection between master and slave are not interrupted, then we do the synchronization in real time. However, if for some reasons the connection is interrupted, so we use the local cache temporarily to support the availability. And once the connection is re-established, we can restart the synchronization in order to get the updated information. So through this model, we can ensure at the same time the performance and the availability. And also, here the very important thing that instead of using a general or global policy for the whole OpenStack, here we use one policy for each tenant in each tenant or project in OpenStack. So at the admin of the tenant, I can specify my own policy for my own usage. I can use a role-based access control. I can use multi-level security, or I can define my own security policies instead. And also, a very important thing that since through the microservice architecture, so we have the Kubernetes to deploy the pod for each tenant manager for the scalability issues. If a very large tenant needs more control capacities, instead of using one Docker, the Kubernetes can scale out and scale down. So here, for high availability, for high availability, Kubernetes, through its scalability models, we can resolve this problem. For the denial of service, and since we have the master and the slave approach, even if the master is attacked temporarily, we can ensure that the whole telco data center always works. At the end, for some kinds of security issues like man-in-the-middle attack, we have some internal connection can be secured in order to avoid the man-in-the-middle attack. So I go back. So OpenStack, a very good platform to support the cloud computing. However, from telco side, the requirements are strict. For some reasons, we needed to improve like the security, the availability, the safety of the platform. And for this reason, we add another upper layer. We call it the control plane, the IAM control plane, in order to ensure this. And this is the role of the Moon project, which is hosted now in OpenStack.
Yeah, so basically, we talked about the external PDP that one presented. We have OpenStack on the other side, right? So we need to make a way to make that connection, right? So what we came up with is what we refer to as an external PDP hook. In a sense, the hook is based on a new private function in a OSLO policy check. And the intent of this hook is basically to redirect the authorization to the external PDP. So it's very straightforward. And you can decide, in fact, if you want to continue with using the local role in the policy or delegate the authorization to the external PDP. So from a technical perspective, it was not a major challenge. That said, I want to emphasize that the collaboration aspect that we had between Orange, Red Hat, and the upstream community, actually the process went fairly quickly in a sense. And it shows when we bring the right people together, then things tend to move at a good pace. Just to tell you, like the spec was proposed in August 2017. We attended PTG in September, the following months in September as well. And the spec was merged, accepted, of course, and then the implementation took place. So just very much short time to get this up and running. If we go back to what I showed you earlier about that read-only rule that we define for that specific user, so basically you remember like we have still a definition and the actual rule that we apply, which was just list the OpenStack instances. Then before the external PDP, we have that description with those two lines. Then when we include the external PDP, now we replace the actual rule checked by the external PDP. So very, very straightforward. What I want to emphasize here is, of course, we do the delegation toward the external PDP, but this doesn't fix all the, I would say, the issues that we have with the OSLO policies, right? There is, if you go from one service to the other, we have noticed that they do not behave at all the same way. And the goal in the community is to have kind of a consistent behavior between all those services. We came into, during the testing with the Moon, and we came across some instances where, for example, Neutron Services was bypassing the check for the admin role. So there are many things that need to be worked on, and the external BDP is not going to address those. So there are some fundamental issues that need to be resolved to make proper use of the external PDP. So this is, I invite the community to work on this upstream for sure. In a summary, what can we say, right? We know that the telco have a unique set of requirements that are not met properly today in OpenStack. But by working closely with the subject matter expert, we can bring those requirements to the community for awareness and possibly finding solution. We have seen two approaches, right? Either I treat each data center independently, I define the role in each keystone for each OpenStack in each data center. I do my role assignment for each instances, each data center, and the policy assignment the same, right? But I need to have some type of umbrella system that can drive all those changes, right? Of course, maybe if you have few data centers, maybe that may work, but when you go with 100, maybe this becomes a scale issue. So the second approach that we took when it comes to authorization was to have the external PDP, right? So with the idea that to centralize the role, centralize the assignment, and the policy definition themselves. And that's what Ron presented with Moon. Of course, this is the two approaches we consider, but there are probably other that basically either we haven't think of or that basically we haven't researched enough. Just a few references. So we have the GitHub for the Moon project. We have the blueprint and the spec and the code for the external PDP, and the work that was done around Open Daylight.
So as a conclusion, so now since the Queen release, you can activate dynamically the Moon module instead of the native Keystone authorization module, just by configuring in the policy.json file this URL. You put the URL of your Moon engines, the control plane, and then all the requests will be redirected to the centralized policy engine instead of using the native OSLO.policy or the Keystone authorization module. And at the same time, as we explained here, at the end, if you use the SDN Controller Open Daylight, you can also activate dynamically the Moon policy engine, inputting directly the URL of the Moon policy engine. Okay. That's all for the presentation. I don't know if you have some questions.
Hi, thanks for presenting. It's a very learning session. Actually, you said other approaches. So interestingly, we have a topic on dynamic RBAC. It's at 3:30 today. I'm from AT&T. So we exactly ran into the same problem. We started this centralized keystone, and now every data center is having its unique keystone. Then the problem of how do we define the roles and distribute it consistently, right? We didn't look at the Moon approach, something that I learned today, but we have taken our own approach in solving that, and we are still leveraging the RBAC, which is coming outside of the box from OpenStack. So if you guys are interested, come over to the session, we can talk more about that and collaborate. Thank you.
Yeah.
You mentioned briefly testing of this, and I'm curious what tools or how you did that.
The testing of the policy engine or the test of the whole platform?
Of the whole platform,
okay,
using the policy engine.
Yeah, okay. Firstly, we test the policy engine, means that the performance, how many requests it can support at the same time. as I explained, it's based on microservice architecture. So for each Docker, it can support at least 70 requests per second. However, we should understand through the Kubernetes, we can easily scale out the capacity. So if we have more requests, you just scale out these policy engines. So my question for the performance of the policy engine is unlimited thanks to Kubernetes. And I go back to the question about the whole platform. We did, at Telco, we need a very stable platform. So we did a lot of tests. Means that we test the number of, we test just one master and one slave with the connection, how much time it should take to have the maximum capacities of authorization. The answer is it's about 10 seconds to reestablish the capacity. And then we do another test to understand how many slaves this architecture can support. And now, through a very simple platform, it can up to about 20 slaves with one master.
So I should have been clear. I wasn't really asking about performance testing, but more functional testing. How do you test that the policy works, that it does what you think it does, and it doesn't break things?
Policy itself through the Tempest. And through the Tempest project, we define our own Tempest models which specify the policy testing. Thanks to Red Hat, we do together these tests.
So I think you're referring maybe to the patrol.
Yes.
So that, okay, so just a little plugin for patrol. I mean, we need to increase the coverage of in patrols for all the OpenStack services.
Yes.
I mean, this is, we need to, basically, policies are complex. We need to automate the testing. So, I mean, to avoid regression, I mean, going from one release to the other, the API tend to change. There is some refactoring. API are deprecated, new API are introduced. So we need to have an easy way to test those policies and enforcement.
But I guess it's something that we need to further investigate also, because as Patrol is using policy.json file, it keeps the structure of airbag, so not sure that it's fully made the test of other external policies, not airbags.
Question is about the PDP engine. Is it centralized? So if I have maybe potentially 100 or 1,000 OpenStack clusters or regions, do I use one centralized PDP, or what's the implementation of the PDP? What kind of replication or resiliency do I have for that PDP engine?
We have one centralized PDP. However, as I explained, we use the master-slave architecture. Means that if we have 1,000 data center, OpenStack data centers. So we have one centralized PDP. However, for each data center, we have a local PDP. We call it a slave. So all the information data set related to this local OpenStack will be cached to this local PDP. And we set up a protocol to do the synchronization between the master and the slave. The reason why we defined it as so complicated data models here is that through this meta model, we can easily update only the modified information instead of update the whole policy. So you can see here, we have a lot of building blocks for the data model. So each time when the user changes just one thing, it will change only one building block. The update will only be done through this building block instead of the whole policy.
Thank you.
You steered clear of Keystone Federation. Was that primarily because of issues of scale? Or were there other complexities that you're looking at?
Well, I don't like Keystone. I can explain the reason why Keystone, I don't like it. First, initially, Keystone is used for authentication. However, later, we like to use the same Keystone for authorization. That's why we defined it in Keystone roles. But the policy itself are not defined in Keystone. It's defined in OSLO policy. And it's defined for each service, Nova, Neutral, etc. And how we can handle all this together, this is a problem.
Yeah, and maybe some other comments. I'm not sure, so maybe I'm wrong here, but I'm not sure that you can guarantee the full independence of your data center with Keystone to Keystone Federation. This is one point. And there is a question also, how do you Because when you are using federation, you get the, so how do you grant the role to the user on the service provider? Because it's based on, so the roles that you grant it to groups, and this is based on, so the groups are associated to the identity that you are federating. And it was something that I would need to check, but I'm not sure that you can get the same role from the Keystone identity provider on the remote Keystone. But, yeah. So it's for identity authentication, but not guarantee the same role assignment across a different data center.
So as a conclusion, the reason why we propose this presentation here, because we think that there's a gap between the OpenStack and Telco OpenStack. So the manner that public cloud or private cloud use OpenStack are totally different from the manner that Telco use OpenStack. And we talk a lot about NFV. However, some real issue, as we presented here, has not been yet resolved. Okay.
Thank you.